What is the final velocity of a box of mass 5 kilograms that slides 6 meters down a frictionless incline at an angle of 42 degrees to the horizontal? Our system will be the block. Since we're assuming no friction, there are no external non-conservative forces, and we can use the conservation of total mechanical energy. What types of energy are involved here? We've only talked about 3 types of energy, and in this case we only have gravitational potential energy and kinetic energy. So here's our conservation of total mechanical energy. It's always good to start there just to make sure you include everybody. And what do we leave out of that? Well, there's no spring, so we lose this term, and we're right here. And then we label our incline. Here's the distance it slides down, here's the mass, here's its initial velocity. And just to save on notation, if we don't have an F, we'll assume that it's the final position. We now substitute in our equations for the different energies. And what do we have to find for h, our initial height? We have to use a little bit of trig there, right? Because they gave us d, which is 6. But what we're going to do is find the height of the incline, and that's going to be d sine theta, so that will be 4 meters. Our initial velocity is 0, and our final height is 0, and we want to find v. Here's our equation again. We get rid of the quantities that are 0, do a little algebra, and we find that the velocity at the bottom is the square root of 2g times our height, h0. Put the numbers in and we come up with a velocity of 8.9 meters per second. What's interesting about this formula right here is the exact same formula you would use to find the velocity of an object falling 4 meters on the planet Earth. And there we can use the third kinematics equation.